Now, I think it's important that we went through all of this by hand, okay? Because I guess you think about it, we could have just skipped to this part and said, hey, this is how I do it with Excel, here's the p-value, and this is what the p-value means. But you kind of don't get the inner workings of everything. You don't understand why is that p-value, why is a small number a good thing? What are we talking about when we talk about significance level in a rejection region? So this is kind of where we're headed, though. This is where we would be headed. So what I want to do is, let's just do one, and then we'll do one together. I'm going to do hypothesis testing of the mean, use test statistic workbook, and z-test mean. Okay, so let's look at, out on Blackboard, under Chapter 10, hypothesis testing, there's a workbook called teststatistics.xls. I want you to bring that up, teststatistics.xls. Okay, and do you remember we used that, I think it was called estimators.xls in the previous chapter to do estimation. And we said, hey, there's a bunch of different worksheets in this workbook. And we looked at z estimate mean and z estimate proportion. Well, right now in this workbook, we're going to use z test mean and z test proportion, just like we've been doing up here. So let's go to z test mean and see what it's looking for. Okay, and then we'll go from there. Z-test mean, just like estimation, all the input parameters are on the left-hand side. It says it wants to know the sample mean. Go ahead, Katie.
Where is this
It's under in Blackboard under Chapter 10. About halfway down, you'll see teststatistics.xls. You see that? Okay.
Yes.
All right, I'll slow down then. But you found it, right? So, on the left-hand side is all the input parameters. Okay, we're going to input a sample mean, which is our test statistic, right? And we already know how to calculate out sample mean, so that's all good. It wants the population standard deviation, but we don't have that. So what are we going to use instead of the population standard deviation? What do you think we're going to use instead of the population standard deviation? The sample standard deviation. Okay. The sample size we're going to know. The hypothesized mean, we're going to know because that's what we're hypothesizing. And alpha, which is our the rejection region, we're all going to know as well. So we're going to put that in. So here's what I'd like to do. In your book, and we're actually going to go, these are actually in the next chapter. But I would like to do numbers, let's see what I assigned for homework. We're just going to do our homework today. So you don't have homework over break. I would like to do 12 and 14 on page 181. Okay, so 12 and 14 on page 181. Let's see, I'll see if I can project it up here. That focused? That focused? Okay. What's wrong?
It's taking forever.
Still low.
Oh, it's still loading for you guys? Okay. How about yours, Katie? Is yours low? Yeah?
I don't think it's not gonna last.
You get priority bandwidth.
What's that?
Try clicking on.
This is on page 181. It's under chapter 10, and it's called the test statistics. It's a workbook. No, we use estimators.xls. It's cousin. All right, let's look at this. Because of the enormity of the viewing audience firms that advertise during the Super Bowl create special commercials that tend to be quite entertaining. 30-second commercials cost $2.3 million during the 2001 Super Bowl. What did they cost this one? $4 million, I think, right? A random sample of people who watched the game was asked how many commercials they watched in their entirety. Do these data allow us to infer that the mean number of commercials watched is greater than 15? So even though we're going to do this with Excel, let's set up our hypotheses. What are we trying to prove here? What are we trying to prove? We're trying to prove that the average is greater than 15. So our null is mu is equal to 15. All right, if we go to our estimator workbook, which I know some of you haven't been able to bring up, there is a tab called z-test mean. Okay? We need to give it the mean of the sample. We need to give it the standard deviation. We need to give it the sample size. We need to give it the hypothesized mean, which in this case is 15. And we need to give it our alpha. It didn't give us an alpha, so we're just going to assume 0.05. So let's bring up the data. If I go, this data is in chapter 11, so if I go to Blackboard and I go to book Excel files, chapter 11, and this one is number 12. So we have this information. So the first person watched 37 commercials in their entirety. Next one watched 11. Next one watched 19. The next one watched 12. How do I analyze this to get the mean, the standard deviation, and the sample size? What would you guys do to do that? Well, there's a lot of different ways we could do it, but what's the way that we went back through in Stat 301? Kind of does it all in one fell swoop. Do you remember? Very good. If I go over to data analysis, descriptive statistics, I click OK. It says, where is my input data? Well, my input data, I'm going to click on the little spreadsheet here and highlight A1 down to A117. It is grouped by columns. There are labels in the first row. I want a new worksheet ply. And I want summary statistics. Do you guys remember this? I click OK, and it tells me this. It tells me X bar, my sample mean, is 15.26. That is my test statistic. Well, 0.267. Let's give it the 7. It tells me my count, which is my n, is 116, and it tells me my sample standard deviation, which we're going to use for population standard deviation, is 5.72. You guys follow me where we got all that information from? So if we go back over to our workbook and we plug in that information, sample mean is 15.267?
Yep.
My standard deviation is 5.7, right?
7.2.
5.72. My sample size is 116. My hypothesized mean is 15, because that's what I set it equal to. That's what I assume it to be at the beginning, right? And we'll just assume alpha is equal to 0.05. Okay. So we plugged in all the data. Now let's look at the results it gives us. It tells us my z test when it converted it to a z, that 15 point, it got 0.5. Well, guess what? All I really have to look at here is one value. What one value tells me my results? And here's the critical one tell, that's 1.645, that should be familiar to you. But there's really only one value I need to look at here to know if this is enough evidence. What one value do I want to look at? What one value on this right-hand side do I need to look at? Someone? Yeah, the p-value is 0.30. So how much evidence is there to prove that we can say the mean is greater than 15? In a word? None, right? What if I did this same test, I had the same evidence, and I'm trying to prove that it's greater than, let's say, I don't know, let's say 12. So I'm going to change my hypothesized mean to 12. So the evidence is still 15.267. Is there enough evidence to say that it's greater than 12? If I was trying to prove it's greater than 12, look where it changed my p-value to, 0.0000. So in a word, if I'm trying to prove that it's greater than 12, how much evidence do I have to prove that? Overwhelming evidence. So you see how that p-value is really the one-stop shop. Okay, so really the one-stop shop. I would like you guys, does that make sense? Okay, the process we went through. Here's what I'd like you guys to do. Okay, I'm going to ask you if you would do number 14. And I'll put it up on the board. But I'd like you to do number 14 on page 181. That 14? Okay. So I'd like you to do 14 on page 181. Okay, so let's take a look at this one. It says, companies that sell groceries over the internet are called e-grocers. Customers enter their orders, pay by credit card, and receive deliveries by truck. A potential e-grocer analyzed the market and determined that to be profitable, the average order would have to exceed $85. To determine whether an e-grocer would be profitable in one large city, she offered the same service and recorded the size of the order for a random sample of customers. Can we infer from these data that an e-grocery will be profitable? So in this case, we're trying to prove that the mean is greater than 85. So again, we are going to go to our data, go to Book Excel Files, Chapter 11, and let's do number 14. We have the average orders, we want to analyze this, we're going to use data analysis, descriptive statistics. I'm going to highlight the data, A1 down to A86. Labels in first row, summary statistics, click OK. And I get 89.266 for my X bar. I get my sample standard deviation is 17.29. And my N in this case is 85. So I go back to my workbook and I enter in the data, 89.26. Population standard deviation is 17.29. Sample size is 85. My hypothesized mean is also 85. And I can leave my alpha at 0.05. So in a word, how much evidence do I have to prove that this e-grocer would be profitable? In a word, how much do I have? I have strong. What value did you look at, Nora? Okay. D4, which is the p-value for a one-tailed test, or 0.0116. So I have strong evidence to infer that this e-grocer will be profitable. Does that make sense? You guys understand that? Not so bad. Let's look at one then with a proportion. And I'm going to go back here to chapter 10 now. And let's go to, let's see, material by chapter. Can't remember which one I assigned here. Hypothesis testing, chapter 10. I did assign 10 and 11. So let's go back to page 166. Let's do number 10 together. God bless you. Okay, it says the results of an annual claimant satisfaction survey of policyholders who've had a claim with State Farm Insurance Company revealed a 90% satisfaction rate for claim service. To check the accuracy of this claim, a random sample of State Farm claimants was asked to rate whether they were satisfied with the quality of service. 1 is satisfied, 2 is unsatisfied. Can we infer that the satisfaction rate is less than 90%? So what are our hypotheses here? Let's start out with that. What are our hypotheses? What are we trying to prove? What are we trying to prove? In StatEase or in English? What are we trying to prove? Mark?
That satisfaction rate is less than 90%.
Okay, and the satisfaction rate is a rate, so it's a proportion. We're trying to prove that P is less than 0.90, so our null is P is equal to 0.90. All right, well, let's take a look at, go back to our workbook and see what we need to use that workbook. If we look at the workbook, there is a tab called Z-test proportion. That's the one we want to concentrate on when we're testing a proportion. It needs the following things. It needs a sample proportion, it needs a sample size, it needs a hypothesized portion, which we have as 90, and it needs an alpha, which we're just going to leave it as 0.05. So let's go look at my data. This is what, number 10, what number was this? This was 1010. So let's look at my data. So if I go to book Excel files again, and I go down to chapter 10, and if I go to XR 10 and 10, here's our data. And let's see, one men satisfied and 2 men unsatisfied. So how are we going to get our P hat, and how are we going to get our N? That's all we really need in this case. So give me one way to get it. There's actually 2 ways I can do this, or maybe 3 or 4, but give me one way I can do it. The way I would do it would be a pivot table, okay? So if we take that data, highlight it, insert, pivot table, put it in a new worksheet ply. I'm going to drag that to the row area, I'm going to drag it to the value area. And hey, it looks like, did one mean satisfied? I can't remember. One men satisfied and two men unsatisfied. So in this case, the satisfaction rate was 153 out of 177. So that's still not my p hat. How would I get my p hat? I could, on my calculator, divide what? 153 by 177. Do it in Excel. Or, if you guys recall, I can go down here to value field settings. And instead of showing it as a count, I can show it as a percentage of the grand total. So, looks like 86.44 is my p hat. If I go back to my test statistic workbook, my sample proportion is 0.8644. My sample size is 177. My hypothesized proportion is 0.90. And I leave my alpha at 0.05. And what do we get over here? Okay, what do we get? What one value tells us how much evidence we have in this case? Go ahead.
0.05%.
Okay, 0.0572, which means we have what kind of evidence to prove that it's actually less than 90%? Well, not quite strong. It's weak evidence, but it's leading us that way, yes? It is. It's leading us to say, hey, I don't think it's quite 90%. So how would I, if I wanted to, before I went in there and called State Farm a liar and threatened to sue them, all those good things, what might I do to strengthen my confidence? Sample more. Does that make sense? Yes. All right, what I'd like you guys to do, same thing we did. You can use COUNTIF if you like. I know some people like COUNTIF for some reason. I would like you to do number 11. Okay, same page, number 11. So after we get back from break, I will also have an Excel assignment for you guys using this, okay? Probably won't be as big as the last one, probably only be 3 or 4, and we'll probably do one in class, just like we did last time. Never loaded, Brianna?
It is.
It's
I-
just loading.
No, I got it to load.
Oh, okay.
but No, everything else is slow.
Load for me.
This Excel file won't load for you.
Yeah,
They're taking like 5 minutes each.
Oh, sorry to hear that.
Just gotta load.
No, it is.
Chapter 10.
When you guys are on other internet sites, websites, is it that slow?
Is it because we're just doing it all at once?
slow.
It should be, because it's a website. You know what I mean? It's not like, if it was a shared network folder, then it would lock it out. Like if you were doing it, it would lock it out so Eric could use it, but because it's a
This happens in
website.
your Excel class every morning, like when we all log into
Yeah.
Blackboard and try to get into whatever you're doing. It's
Yeah.
slow for all of us, except for like 2 people that got there first.
Huh. It should.
Yeah.
Maybe the access.
It could be, it's probably the access point, more than the access point. That's probably the choke point, yeah. I mean, if you guys went on right now and everyone, played what does the fox say in YouTube, it wouldn't slow down because all everybody, it might slow down because everyone was hitting our access point at the same time, but it's a website, so there's no contention issues. So, Professor of Business Statistics recently adopted a new textbook. At the completion of the course, 100 randomly selected students were asked to assess the book. The responses are good, excellent, good, adequate, and poor. The results are stored using the codes in parentheses. Do the data allow us to include at the 10% significance level that more than 50% of all business students would rate the book as excellent? Okay. So what is our proportion? What is the thing we're testing here? We're trying to say that P is what in this case? P is greater than 0.50, right? That more than 50% would say the book is excellent. So I need to go to my data. So if I look XR10-11, and it opened right up for me. And 1 meant excellent, 2 meant good, 3 meant adequate, 4 meant poor. So once again, I want to count the number of ones. So let's do it, since we did it with the pivot table last time, let's do it with the COUNTIF statement. So my data is from A2 down to A101. So I'm going to do equal COUNTIF. I'm going to look in A2 to A101, and I'm going to count the ones that I find. So 57 out of 100 rated the book as excellent. So I guess I don't have to do that math. 57 out of 100 is 0.57. So if I go to my test statistics, 0.57 is my p-hat. My sample size is 100. My hypothesized proportion is 0.50. And I can go and look at one value. My one value is 0.0808. That's my p-value. And it appears that there is some evidence, but in a word, how much evidence does this sample provide me? Weak evidence with a p-value of 8%. If I make this claim, there's an 8% chance that I'm wrong. Okay, that's the probability of making a type 1 error in this case. Okay. What questions you guys have on doing that? Nora, you have a question?
Should we always keep the alpha at 0.05?
You know what? Neither of these problems gave it to us. Okay, none of these problems, these 4 problems I did. So if a problem doesn't give you 0.05, giving you an alpha, just assume it to be 0.05 always. Okay, that's kind of the standard. Now, if it was 0.05 and we had a p-value of 0.08, we probably wouldn't reject the null and favor the alternative. But a more precise way to say is that, you know, I have weak evidence to support that, or, you know, I have nearly significant evidence. Okay, so yeah, if it doesn't give it to you, leave it at 0.05, all right? What other questions might you guys have? Okay, so no homework over break. That's what breaks are for. Enjoy yourself, but come back, refreshed, recharged, renewed, reinvigorated, read whatever it is, and we will hit it hard when we come back. There will be an assessment, probably not the week we come back, a test, but probably the week after, on hypothesis testing. So I'm going to make sure that you're well prepared for this. And then, truthfully, the subsequent chapters are more of the same. They're more estimation, hypothesis testing using different techniques. I am, over break, also going to put together, I think I mentioned at the beginning of the class, in the syllabus, it's going to be like a project toward the end of the class where you have to apply what you've learned. So I'm going to put that together, put the finishing touches on that. We'll go over that when we come back as well. So have a good time on break, but be safe. You know, you're not invincible. You're 20, 21, but bad things happen to all ages, so be safe.
What is the name? When do you think you so?
I don't know. I don't know. Probably that following week. I'm not sure. I might not do it this time. I don't know. Enjoy yourself. Golf well.
I was so excited. I was walking in class. I was like, I hate Loretto. Get him.